Inequalities. The cool thing is a lot of you have seen this before, so it would be pretty easy. At least some of you. Oh yeah. Get your stamp sheets out. It counter notes inequalities. No, we're good with off for now. While I'm coming around the stamping, you go ahead and write the definition of the inequality. Let's get right into the definition here. So, greater than, less than, greater than or equal to, less than or equal to. Let's review what these mean. Example 1. When I write x is greater than 8, how would you pronounce this? Well, you pronounce it this way or this way. I'm going to put quotations there. So x is greater than 8. Notice the Pac-Man. That's the way I memorize it when I was your age. Is I'll just pretend this symbol is the Pac-Man wants to eat whatever is greater. So x is greater than 8. Or I can say this as x is less than 8 if I want to read it from right to left. X is greater than 8 or 8 is less than x means the same thing. It's the same truth value. So we have an infinite amount of solutions. Any values of x that are greater than 3, what we're going to do now is we're going to graph it. We're going to graph what x can be on a number line. Let me show you what I mean. Let's graph. So I'm going to draw a simple number line. Okay, only x. We're not doing it with y here. We're only doing it with one variable equation here. So I'm only drawing an x-axis, an x number line. What I want to show, I want to depict the numbers that are greater than 3 on my number line. So let's see here. I'm going to put the number 3 here. I'll put the number 2, the number 1, and so on. I'll put the number 4. I'll put arrows because the arrows indicate that the graph goes on infinitely, right? So, let's graph x is greater than 3 on our number line. We're going to show all the solutions, all the possible solutions that will satisfy this inequality. So, my question though, will 3 satisfy the inequality? No. Right. It would have to be equal to negative positive 11 if 3 would satisfy. But just for the doubters in here, let me just verify that 3 doesn't work. Look what I'm gonna do. Just pay it. You don't have to write this down, but watch me do it. 3 times 3. See, I'm seeing if 3 satisfies. Plus 2, is that greater than 11? Let's see if that satisfies. So I got 9 plus 2 is greater than 11. 9 plus 2 is 11. Is 11 greater than 11? 11 is not greater than 11. 11 is equal to 11, but not bigger than 11. So 3 does not satisfy this. Only anything greater than 3. Look at x has to be greater than 3, not equal to 3, greater than 3. So that means the number 3 on my graph, I'm going to put an open circle. Do that with me. I put an open circle at the graph at the number 3 because that's communicating that 3 is not a solution. Only numbers bigger than 3 are solutions. So I'm going to shade all the numbers bigger than 3, which means I'm shading to the right. I'm shading everything to the right. This is communicating, look, any number bigger than 3 is a solution. In other words, pick any number from this area, any number you want. It'll satisfy the inequality. Pick any number. Ibarra, can you give me a number bigger than 3? Thank you. Watch this. I'm going to pick Ibarra's solution. I'm gonna test it, in other words. You don't have to write this down, but I'm gonna test 21. Ibarra picked 21. 21 is definitely part of this shaded area. It's way over here, but still part of the shaded area. Watch this. 3 times 21 plus 2, is that greater than 11? Let's see. 3 times 21 is 63. Plus 2 is greater than 11. 63 plus 2 is 65. Is that greater than 11? Absolutely. It works. It's satisfying. It resulted in a true statement. That's cool. You come in late and you just look at your phone. Nico, really? Oh, sorry. Your phone's out. Thanks. So it satisfies any number greater than 3. Cool. I trust that was clear. Let's try another example. Yes. This will be example 2. All right, example 2. This will be the last example for the day, I think. All right, example 2, please. Example 3, thank you. 7 minus 5x greater than 9 minus 4x. 7 minus 5x greater than 9 minus 4x. So what I want us to do here, here's the mission. We're going to solve and graph. We're going to solve and graph. Let's do it. All right, so we'll treat it the same way we do equations. Let's get x alone. So let's treat it the same way. So I have x on the left and on the right. Let's get them on one side. So what I'll do is I'll add a 4x to both sides. So that this way we can get x's on one side. All right? Okay. So negative 5x plus 4x becomes a negative 1x. I got a 7 here. I got a greater than symbol. And I got a 9 on the right. So far, so good. What I'm going to do is I'm going to put a plus negative here, just so I know that this is a negative 1 in front of the x. This way there's no confusion in my mind that I'm dealing with a negative 1x there. So we've got to start proceeding to isolate x. Let's get x alone. Let's undo addition. So I'm adding the 7, so I'll subtract the 7 from both sides. Bring down the greater than symbol. So I have a negative 1x greater than positive 2, right? Now, if anybody remembers inequalities from math classes prior to me, there's something special you have to remember here. We flip the symbol if we divide or multiply by a negative number, which we're about to do. Thank you, Rodriguez. Check this out. So what I'm going to do, we can still have to get x alone, so I'm going to divide by negative 1. Okay? If I divide or multiply only, dividing and multiplying, it only works. We flip the symbol, the inequality symbol. So I end up having x is less than a negative 2. So what I want you to do on your notes, put a little star here so you remember. I want you to put a star on this step here. And put it right in underneath the star, just so you remember. When you divide or multiply by a negative number, the inequality flips. Symbol flips, I'll put it. Okay, that's what I need you to remember. That's the only feature of difference when we're dealing with inequalities versus equations. Everything's the same, getting x by itself. It's just when you divide or multiply by a negative number, that symbol flips. Hold the question real quick. Let's graph now. Well, before I graph, I'll take a question. Yes?
Oh, absolutely. Because I added 5x.
That's fine. So let me actually like that. Let me tell you what, let me graph it, and I want to do it the way you did, because just for the sake of students who are still kind of confused about those options, I like that. Thank you, Chris. Let me graph this first. So we have our solution. X has to be any number less than -2. Let me put the graph over here. So let's graph that on a simple x-axis number line. So here's my number line. Here's -2. I'm just going to put -2 here. I don't have to put the other numbers. On the previous example, I put all the other numbers here. It's really unnecessary to write all the numbers. Just put the number that you're dealing with, and it's sufficient. I know where the numbers are at. You know where the numbers are at. It's unnecessary to write a bunch of numbers. I'm just going to put the number I'm dealing with, -2. Can x be equal to -2? No. So I'm going to put an open circle. X can only be less than -2, so I'm going to shade in everything that's less than -2, which is to the left. There's my solution graph. That's telling us, look, you want something that's going to satisfy the inequality? Well, then just choose any number from that area of the number line. Anything less than -2. That'll satisfy this original inequality. What I want to do really quick is solve this inequality using Perez's method. Okay, I'm just going to erase just the work here. I'm going to not the solution. That'll be a good review here. So you isolated x on the right side. So check it out. Here's what Perez did. You added 5x to both sides? So if you add 5x to both sides, look what ends up happening. I have a 7 on the left greater than, I got a 9 plus an x. Because -4 plus 5 is positive 1x. Now to get x alone, I'll subtract 9. And look at the same, it's the same solution. It's just x is going to be on the right side. 7 minus 9 is a -2. Look at x is still less than -2. It's just it's on the right side. Or -2 is greater than x. X is less than -2 means the same thing. So that's the alternative way. Still be the same graph, same solution set. Okay. Questions on that? Example 2. I'm only going to do 3 examples today. That's it.